So here's our last lesson of the year. Objective 5.8b, solving log equations, advanced. So your objective, you can use the log properties and your log exponent conversion skills to solve more advanced log equations. And I asked you to write down these 3 questions because these are the questions you should ask yourself before you begin to attack a problem. Question number 1, can I create the situation a log equals a log? Those are the easiest ones to solve. Question number 2, can I create the situation where you have a condensed log equals a non-log, equals a number? Or am I in the situation where I see a cubic or a quadratic and I have to find the zeros? So I have to actually factor. So I have to take it, make it equal 0, and factor it out. So these are the questions we're going to ask ourselves. Starting with example 1. So if you could write that problem down, we have the log of 5x minus 6 divided by the log of x equals 2. And we are going to have to train our brain to think about this for a second. This is going to answer question 1. I'm going to create a log equals a log. I want to make sure that you understand that this side of the equation is not a condensed log. It is a log divided by a log. Okay, so let's just look at the difference between a condensed log. You can just watch. Okay, a condensed log would look like this. The log of 5 over x. That's a condensed logarithm, where you see log 1 time. And this means the log of 5 minus the log of x. That's what that means. This does not say that. This is not condensed. This is a log divided by a separate log. So what I'm going to do to solve this problem is I'm going to clear the fraction. Multiply both sides times the log of x so that I can cancel the left and clear the fraction. So you have the log of 5x minus 6 equals 2 times the log of x. And so this 2 is not a separate term from the log of x. What I want to do is start each side of the equation with the word log, so I'm going to use my power rule for log properties that says the power times a log is the same as the log of a power. So we're going to power that up. Log of x squared, power up. Okay, so clear the fraction. Power up. Now we have a log equals a log. And we know the rule, log property A. Excuse me. It says if we have a log of a number equals a log of another number, then the numbers are equal. You can essentially just drop the log and solve the remaining equation. Okay, so I see a quadratic here. Yes? Which means to solve it, I'm going to have to factor. So can you imagine that I'm subtracting 5x and adding 6? So we have x squared minus 5x plus 6 equals 0. And then we're going to use either our factoring skills or we're going to use our quadratic formula. Always try to factor first. So I'm looking for the factors of 6 that add to negative 5. That's a positive 6. Have to be the same sign. So negative 2 and negative 3 would satisfy those conditions. So we have x minus 2, x minus 3 equals 0. So you can probably see your zeros now. X is either equal to 2 or it's equal to 3. And of course, at this point in our careers, we're skipping the step of setting each quantity equal to 0. We can do it in our head. Okay, before we decide that 2 and 3 are our solutions, of course, when we're solving log equations, we have to make sure that we don't create a restriction or a domain error. So we have to actually check our answers. So we'll check with a 2. So the log of 5 times 2 minus 6 divided by the log of 2 should equal 2. And of course, you can just plug that into your calculator, and it will tell you your solution, or you can continue to work it by hand. That's the log of 4 divided by the log of 2 equals 2. And then you go through that same process that we just went through, where we're going to multiply log of 2 to the other side and cancel that out. Then we'll power up, and you get the log of 4 equals the log of 2 squared. And then, of course, if logs of numbers are equal, then the numbers are equal, and 4 equals 2 squared. Therefore, we can say 2 is a good solution. And then, of course, you're going to go back in. And what's nice about my pen is I can just erase, right? Yes? And redo. So this time we're going to plug in a 3. So that's the log of 15 minus 6 log of 9 over the log of 3. Then we'll multiply both sides times the log of 3. And we'll power up. So that's the log of 9 equals the log of 3 squared. So 9 equals 3 squared. That's true. So we didn't create any a log of negatives, which are restrictions. So both of those solutions are good, and we will keep them. Okay? Remind yourself, if you forgot, that the log of a negative does not exist. Domain error. Questions about that? Okay, example 2. So here we have the equation, the log of x minus 2 minus the log of x minus 6 is equal to the log of x over 5. So this is 3 log terms, and I don't see any non-log terms. So I would like to use my log properties to condense the left side of the equation into a single log of 2 numbers instead of separate logs of 2 numbers. So I have a log equals a log. So if I'm subtracting the logs of 2 numbers, what could I do to condense it down to 1 log? Division, you got it. So x minus 2 over x minus 6, condensing that, is equal to the log of x over 5. I like it when I can create this circumstance, because then I can apply log property 8 that says if the logs of numbers are equal, then the numbers are equal. So I can pretty much just go, okay, so that's the equation that I'm going to solve. X minus 2 over x minus 6 equals x over 5. And, well, the x's are all over that equation, so we need to rewrite it. I think first I would clear the fraction. And since I have a fraction equals a fraction, the quickest way to do that is to just cross multiply. So 5 times x minus 2 is equal to x minus 6 times x. So I'm going to go x times x minus 6. That way I've cleared the denominator. And then it's quadratic. I can see it already. We'll distribute. 5x minus 10 equals x squared minus 6x. And because it's quadratic, of course, we have to find our zeros. So we'll move everything, make it equal to 0. So I'll go ahead and write it out since we've got to move a couple numbers. So I'm going to subtract 5x and I'm going to add 10. I'm going to come over here to do my work. So that'll be x squared minus 11x plus 10 equals 0. And then I have to find my 0. So either factor or I use my quadratic formula. I think it'll factor nicely. Yeah, we're looking for the factors of positive 10 that add to negative 11. Negative 10 and negative 1. will satisfy those conditions. So x minus 10 and x minus 1 equals 0. So our zeros are x equals 10 and 1. And then we have those two solutions. And I'm thinking 1 is going to have to be thrown out. But I think 10 will be okay. So I just kind of imagine, before I write things down, if I can just immediately throw any of these answers out or exclude them. When I plug in a 10 here, I get positive 8. When I plug in a 10 here, I get positive 4. And when I plug in a 10 here, I get 2. Those are all positive logs. So 10's probably a good solution. But if I go and plug in a 1, I want you to imagine I plug in a 1. What's that going to create right here? And I can't have the log of a negative, right? So I'm already feeling like 1 is no good, because when I plug in a 1, I'm going to create log of negative 1, which doesn't exist. So there's really no reason for me to continue checking the log of 1, or x equals 1. But we'll do the check with 10. So it's the log. Are you okay if I plug in the 10 up here and just write log of 8? Minus, and I'll plug the 10 in up here. Log of 4 equals the log of 10 over 5. Right? Condense. That's the log of 8 over 4 equals the log of 10 over 5. Can cancel the logs. 2 equals 2. True statement. So we would say that our solution 10 is a good solution and 1 was an extraneous solution. Questions about that? Yes. To 2? Yeah, of course. Absolutely, you could have condensed it right there. Absolutely, or not condensed it, but divided it for sure. Okay, last question. We're going to call this one the beast. Okay? This one is a little bit confusing because not so much the left side of the equation, but the right side of the equation. I want you to know that this 3, this power will power down, but this power of 2 will not, because this is not an x squared. It's the log of x squared. So let's make ourselves a little note right here that this means the log of x times the log of x. Okay? That's what it means. So I can't power down the 2. It's not the log of x squared. It's the log of x times the log of x. They're different. Okay? Also, I would like you to note that this is cubic. Yeah? And over here is a quadratic side, but it's a cubic function. It's a cubic equation because the largest degree is a 3. That means that I can't go with my method where I have a log equals a log. It's going to have more than one solution, so I have to factor. So what I'm going to do is rearrange this equation and set it equal to 0 by subtracting this quantity and moving it to that side of the equation. So we have the log of x cubed minus the quantity log of x squared equals 0. And it might be difficult at this point to see how to factor that. So I'm going to do a little bit of extra work with this. I'm going to power down because I'm expanding so that I can find all the factors. So that's 3 log of x minus, and over here I'm going to expand this statement as well. Log of x times the log of x equals 0. So I've really stretched that out so that you can see the common factor in these two terms. Notice there's only 2 terms. There's only ever been 2 terms. Okay? So what's the common factor in term 1 and term 2? Log of x. So that's what I will factor out. The log of x leaves me with 3 minus the other log of x, which equals 0. So I factored it down so that my x's are all to the first power, which is really helpful. And I'm going to set each quantity equal to 0. So we have the log of x equals 0, which is a log and a non-log PS. And then we have 3 minus the log of x equals 0. So we have to solve for our zeros. So anytime you have the log equals 0, your number's 1. But we'll go ahead and convert it because you have a log non-log that requires conversion. Okay, so we're going to convert from logarithmic form to exponential form so that we can just see the answer quickly. So that's 10 to the 0 equals x. So x equals 1 because anything to the 0 is 1. So there's one solution. Now on the other equation, we've got to rearrange. So I think the quickest way to do that would just be to add the log of x to the other side. Are you guys okay with that? So that I don't have to subtract and divide. So we'll add this to the other side. So, and then I'm going to write it log of x equals positive 3, rearranging left to right. Okay. And then convert again. So that's a log base 10. So 10 cubed equals x. So x equals 3 zeros, 1,000. Okay, so those are your two solutions that we've come up with. Now we just need to check them. I don't think either of them are going to create a negative, do you? If I plug in a 1 here, I get 1, right? So the log of 1 cubed, well, that's the log of 1, and the log of 1 is 0 all the time. The log of 1 is always 0, so that side's done. Over here, we have the log of 1 quantity squared. Well, what's the log of 1? I just told you, 0. And what's 0 squared? 0. So we would definitely keep 1. And then, of course, we'll plug in the 1,000. So we have the log of 1,000 cubed. Well, you know how many zeros that has? 9, right? So that's the log of 10 to the 9th. I don't want to write 9 zeros. And if these two numbers are the same, then these two numbers are the same. So that's 9. And on this side, we do the log of 1,000 squared. Well, what's the log of 1,000 if I write it base 10? 10 to the what? Right? And what's... it's not. Hang on. It's the log of 1,000 squared. Well, that's the log of, count the zeros, that's 3 squared. That's 9. And so that is also a good solution. So we would keep them both. That isn't fish. I don't even know what I drew right there. A fish. He's going to drop some bubbles. Okay. Anyway, there you go. Last questions on your last problem of the last page of notes for this year. Any questions? Okay, summary. And then you're doing problems 41 to 53 odd, and 40 through 54 evens are extra credit. And that's your last homework. Study guide. Yes, I'm good. I'm annoyed, but I'm good. Where did my thing go? Video.